What's up, everyone? In this video I'm going to show you how to solve systems of equations using elimination, and we're going to stick to linear equations kind of like we have been so far in this unit. All you need is a clean sheet of paper and a pencil and you're good to go. Alright, so far we've learned two ways to solve systems of equations, but there are three total that we're going to use. The first one we learned, and we learned this in the last flipped video, was graphically. That's where you graph the two lines, or there could be more than two, but in most cases you're going to see two lines and you look for the intersection. So that's the graphic way to do it. The second way we learned in class, this was the substitution method. Now the third way is the elimination, and that's what I'm teaching you. And the elimination method actually is my favorite way to do it. I do systems of equations probably 75% of the time using the elimination method. But each of them has their place. Sometimes it's nice to do it graphically. Sometimes substitution works out really well. But elimination, like I said, is my favorite. So I'm going to take you through 4 examples, and hopefully you'll get a good feel for it. Alright, so in number 1, I've got two lines. I can tell they're linear again because it's just a plain old x and a plain old y. There's no squared, square roots, any other weird stuff. Now it's not in y equals mx plus b form, but that's okay. We actually don't need it in y equals mx plus b form to solve it by elimination. What we really want for elimination are the x's to line up, the y's to line up, obviously the equal sign to line up, and then the constants to line up. It doesn't necessarily have to be x, y equal and then the constant, but they do have to line up perfectly. Normally what you see is something like this. The second thing we got to look for is, and this is why it's called elimination, we're looking for variables that if you added them, they would equal 0. So you're looking for opposites. Now the negative 6x and positive 9x, if you added them, you would get 3x, so they do not cancel. But take a look at the y's. You've got a positive y and a negative y. If you were to add those, they would equal 0 and eliminate each other. So this one's actually set up perfectly. This is like a lob pitch softball as far as math problems go. So here's what we do, and it's going to look a little weird. As long as you got them lined up, we are going to add these two equations. Seems really weird. I usually circle this just to show that I'm adding the whole big thing here. And we're going to go vertically here. So like I said before, negative 6x plus 9x gives me 3x. Positive y and negative y eliminate each other to 0, so I don't even write anything. And this equals 8 plus a negative 17 would be negative 9. So check this out. I had two variables before, but the y's got eliminated. So now I've just got 3x is equal to negative 9. This is super easy to solve. All I have to do is divide each side by 3, and I get x is equal to negative 3. That was super easy. But remember what systems of equations are, especially with these lines. We're going to have two lines that are crossing, and our solution is an xy coordinate. So all I have right now is the x coordinate of that point. So I need to find the y. So what you need to do is take this negative 3 for the x and sub it back into either one of these two equations. It doesn't matter which one. I'm going to choose the top one. Alright, you'll get the same answer either way. So I'm going to sub this into the negative 6x plus y equals 8 equation. I'm going to sub it in. And make sure you do this with parentheses, especially since we have a negative. So it's negative 6 times negative 3 plus y is equal to 8, and now we're going to find the y. Negative 6 times negative 3 is positive 18. Positive 18 plus y is equal to 8. And then finally, to solve for y, subtract 18 from both sides. And I get y is equal to negative 10. So I got an x is equal to negative 3, a y is equal to negative 10. You can say your answer in two ways. You could either say x is equal to negative 3, y is equal to negative 10, or you could give it in the xy coordinate format, which would be negative 3, negative 10. Either way is okay to say your answer. A lot of times I just do this because it's shorter. Alright, now what you should do is check your answer by plugging it back into both equations, but you already know how to do that, and it would be a waste of time for me to do that in this video. So I'm just going to move on to another example. Alright, next one. We're going to solve this system of equations, and the first thing I want to do is make sure that everything's lined up. X's, Y's equal constant. Good to go with that. We don't have to do any rearranging. So now I'm going to look to see what's opposite, if there's anything that would eliminate. And right off the bat, I can see that a positive 4 and a negative 4 will eliminate each other. So I'm going to add these two. Again, these eliminate each other, go to 0. I don't even write anything. 7y plus a negative 10y is negative 3y. Negative 1 plus a negative 2 gives me negative 3. And now we've got a really simple equation to solve. Negative 3y equals negative 3. Divide both sides by a negative 3. And I get y is equal to negative 3 divided by negative 3 is 1. So this time we found the y first. So now we've got to sub that into either one of these two equations to get the x value. I'm going to choose the top one again just because this one has a lot of negatives, so I'm just going to do that one. So it's going to be the 4x plus 7y equals negative 1. Sub in y equals 1 for that. So this is 4x plus 7 times 1 is equal to negative 1. So 4x plus 7 is equal to negative 1. I'm going to subtract 7 from both sides, and I get 4x is equal to negative 8. And then when I divide both sides by 4, didn't use my space too well here, I'm going to get x is equal to negative 8 divided by 4 is negative 2. So my answer, we could either say x is equal to negative 2 and y is equal to 1, or I can just say my solution is the point negative 2, 1. Again, you should probably check this, subbing it back in, but we are good because I want to stay short on time here. Alright, number 3 is where it gets a little bit different. What you're going to see here is that with the x's are not opposites. We got a negative 4 and a 12. They do not cancel out to 0 or eliminate each other. Neither do the y's. Everything's lined up, which is good, but none of these will cancel right away. So the trick here is to multiply one or both of these equations, and you got to multiply everything by a constant to make it so they will. Well, I'm looking at these x's. I know that negative 4 times 3 would give me negative 12, which would make these cancel out. So I'm going to cancel out the x's, and the way I can do that is to multiply this whole thing by a 3. So check out what my new system of equations is going to be. I'm going to write it over here. When I multiply the 3 times the negative 4, I've got negative 12x. 3 times 10y, that would be plus 30y. And this is equals 3 times negative 14 would be negative 42. Now the second one is going to stay exactly the same, so I'm just going to rewrite it. 12x minus 8y is equal to 20. Now I'm working with a system of equations that these will cancel out or eliminate each other. So I'm going to add now, and it's the same process as what we had before. When I add these opposites, it goes to 0. 30y plus a negative 8y is 22y equals negative 42 plus 20 is negative 22. This actually comes out kind of similar to the one we just did. Divide both sides by 22, and I get y is equal to negative 1. Same process again. I'm going to sub this back into either one of these two equations. In this case, I believe the second equation looks a little bit friendlier. So I'm going to sub this in. So I've got 12x minus 8y equals 20. I will sub in the negative 1 for the y. And got to be careful here with the negatives. Negative 8 times negative 1 is positive 8. And now I'm just going to solve this. Subtract 8 from both sides. I get 12x is equal to 12. So that means when I divide both sides by 12, I get x is equal to 1. So my solution is the point 1, negative 1. Alright, so we had to do a little trickery there, multiplication, to get it to actually eliminate each other. Alright, one more example. Alright, in this example, they are lined up, which is great, but the 2x and 3x do not cancel each other out. The 2y and 8y do not cancel each other out. So again, I'm going to do the similar trick. To me, I think I can multiply the 2y times a negative 4, and that would give me a negative 8y. So I'm going to do that. And I'm going to write my new system over here. So it's going to be negative 8x when I distribute here. Negative 4 times 2y is negative 8y. And this is equal to negative 4 times negative 6 is positive 24. A lot of times people forget to multiply that constant. The bottom one stays unchanged. So this is 3x plus 8y equals 6. And I'm going to pause the video here. I want you to try to work this one out on your own. So pause the video here. I'm going to do it on my own, and then we can check answers in just a second. Alright, so let's see how you did. When I added these two equations, I got x equals negative 6. And then I subbed that back into the first original equation, and I ended up getting y is equal to positive 3. So my solution is negative 6, 3. Now if you didn't get that, you might want to pause it on the screen and check over my work. Alright, let's get to the SIA questions. I've got 2 of these for you to do. Remember, find both the x and the y, and then answer the online quiz. Thanks for listening.